let's see what are the main types of the volatile requirements. It could be mutable requirements or emergent requirements or consequential requirements or compatibility requirements. What are mutable requirements? These are those requirements in which change, like we see changes on those requirements because of the changes to the environment in which the system is operating. That's why we call them mutable. On the other hand, emergent requirements are considered as those requirements which actually cannot be completely defined when the system is specified, but which emerge as the system is designed and implemented. So emergent requirements are volatile requirements because when the system was initially initiated, we don't have a clear definition for such requirements. But but those requirements have emerged, like we were able to define them at this moment, or we were able to see them coming in the system. So maybe at some point those requirements want to change, but they are emerging. They are now linked to the system. The consequential requirements are considered as those requirements which are based on assumptions about how the system will be used. So if you build your, include requirements that are built on assumptions, so once the system is in place, some of these assumptions might be wrong. That means your requirements might be impacted with such assumptions. So they are consequential, aligned to changes based on the assumptions. That's why they are volatile, because once the assumption change, those requirements are also what it change. That's why we call them consequential requirements. Finally, the compatibility requirements are considered as requirements that depends on other equipment, technology, or process. So they are compatible with certain equipment. If you change your hardware, maybe this requirement would change. Or technology, if you change your technology, maybe the requirements would be impacted. Or even the processes of the system, if some of the processes in your system would have a change, this compatibility issue may be impacted, and of course, the requirements that are aligned with the compatibility also will be impacted. So in requirement management, what are the main expectations of managing requirements? So we need to go over certain steps to provide a requirement management process that at the end helps in provide a control to the changes in the requirement, control to divergence changes, trackability of the status of the requirements, and even tracing the relationship between requirements. So to understand requirement management in a better way, we need to provide different phases in one process that would start by identifying of individual requirements, provide traceability from the high level requirement to implementation, from the highest level requirement to implementation. That means to provide traceability to those requirements and the relationship, we need to establish links through requirement databases. We need to obtain links between requirements and even design model and test cases in the code. We need to provide a coverage and consistency analysis, and we need to understand the main traceability policies among requirements from the highest level requirements to the implementations. We need to understand different type of links between requirements and other elements in the system. And we need to also understand from where this traceability could start and to where the traceability might end. After we provide a sustainable traceability scheme to identify the level of relationships between the requirements and other components, or even requirements and requirements, we need to come up with a strategy to understand the impact of the proposed changes in the system. In other words, we need to provide an assessment of such impacts. This would be done by invoking different analysis tools that will let us see which other requirements and even any other links artifacts will be affected by a change. After we do impact assessment of the proposed changes, given the fact that we were able to trace the relationship between requirements and we were able to identify the requirements and requirement changes, we now can provide control access to the current project information in which we have a shared database of all the requirements and the design models and the test cases. So this shared database could ensure that all the users are working with current data. This helps in the consistency and even provide parallel access. Also, to provide a control access to the current project information, we should have a central repository that allows all users to see the information that they need to see, which provide a better visibility of the entire project. So we did traceability, we did impact assessment. Now we should have a control access to the current project information, which is the more or less like databases or repository of what we actually have for requirements and other system elements. And now we need to provide, after all of these informations are collected, and we need to provide an action to the change in the requirements. That means we need to provide a control process for managing the change, in which we need to know how we collect, document, and address such changes. Finally, you need to deploy a requirement tool that helps in supporting the changes and the response to the changes. This tool is really helpful to manage the requirement change. Now let's discuss some of these points separately. I will start now by identification of requirements. It is essential for requirement management that every requirement has a unique identification. So in order to identify the change in the requirement and then provide a response to the change, it's mandatory to identify the requirement. So how would we identify a requirement? This could be by a unique identification. The most common approach to provide a unique identification for each requirement so we can have an efficient requirement management process is requirement numbering based on either the chapter or the section in the requirement document. There are several problems with this approach. The first one is numbers cannot be unambiguously assigned until the document is complete. Also, assigning chapters and section number is actually as an implicit classification of the requirement, which may mislead readers of the document into thinking that the most important relationships are with the requirements in the same section, which might not be true. So this is one problem of unique identification. So there are different requirement identification techniques in addition to the unique identification using numbering. Sorry, I was talking about just like numbering. So requirement numbering based on the problems of those requirement numbering based on just chapter and section in the requirement document. The problems associated with this numbering scheme has created different requirement identification techniques. The first one is dynamic renumbering. So the dynamic renumbering is very efficient when we have the cases in which some word processing systems allow for automatic renumbering of paragraphs and even the inclusion of cross-reference in the requirement document. I'm talking about the SRS. As you negotiate, as you reorganize your documents and even add new requirements, what will happen is the system keeps track of the cross-reference and automatically renumber your requirements depends on its chapter, section, and position within the section. So instead of having a static numbering, or like just have like numbering based on the section and number in a static flow, it might be better to use dynamic numbering to allow automatic renumbering of the paragraphs and even the inclusion of the cross-references. This is if we don't have a database. But if we do have a database, so maybe database record identification is a way to identify the requirements. When the requirement is identified, it is entered in a requirement database in a database record identifier. So this is the identifier that we assign to each requirement, which is then used for all subsequent references to the requirements. So that's how we provide a unique identification to the requirement just by the usage of the database record identifier. Finally, we could also do symbolic identification. So instead of having a number system, maybe we could use symbolic identification, such that requirements could be identified by giving them a symbolic name, which is associated with the requirement itself. You could say section 1. So it's not about just a number. We also use a symbolic name or symbolic wording, key term to each requirement. Section 1 or section 2 or even section 3 that can be easily used for requirements which relate them to system integration and also system security to number each requirement in a unique identifier with a unique identifier. So after identifying the requirements, it's very important to keep tracking of the changes later. We said we need to identify requirements, but apart from the identifiers, requirements also should have attributes. Why we need attributes in each requirement? Because we need to establish somehow context and background about each requirement, and even go beyond the requirement description. If we would like to provide filtering, analysis, and even metric evaluation for each requirement, some of those attributes could be the creation date, the last update of requirements, the author of the requirement, the stakeholders, including the owners and the source of those requirements. We also have attributes related to the version number, status, priority, importance, and stability of each requirement, rationale, comments on each requirement, acceptance criteria, or might be acceptance level for each requirement, subsystem, and product release number. The most complex the project is, the richer the number of attributes. Many attributes are actually predefined in most of the requirement management tools. Other are defined by requirement engineer as required by the project. So requirement attributes can easily be monitored in different databases by defining classes. Within the classes, we define attributes for each class. This step is really efficient in monitoring attributes of each requirement. Regardless of the requirement document, I might use a database to store the requirements and even the attributes of each requirements by identifying different classes, and within each class, we identify the attributes. And this will help on providing unique identifiers for requirements, in addition to monitoring all the attributes that will be linked to the requirements. At the end, we will have a relational database where all the tables are related by different primary keys and foreign keys. So we can now see the attributes and the connections between them. So if there is any change in the requirements, it's easy to go back and see the database and monitor the change. But what's good about this database implementation is we might not need to store all the requirements. We might select only the necessarily, not all the attributes of the requirements. We might select only the necessarily attributes of the requirements. So part of requirement identification was to provide a unique identifier to requirements and also identify the attributes of the requirements and the status of the requirements. Why we need to define the status of the requirement, because it helps the management process to look into the different status of requirements in the requirement lifecycle. Their number and nature depends on the process in place. An example of a state of status, it could be a proposed status, that this could be done by some stakeholders, or it could be approved status, like a proposed requirement or approved requirement. Approved requirement are considered as part of the baseline and they are committed to implement. The rejected status means we have evaluated such requirement and it turns out that we don't need it, or there are unnecessarily usage of such requirement. So we say the status of such requirement is rejected. It could be implemented requirements, and this one is actually designed and implemented, and that means this requirement has been transferred to the developer, the developing team. Verified requirements, mostly related to relevant tests that have been based on such requirements. So we say this requirement is verified, or this requirement is even deleted from the list. So requirement management actually include among its tasks the tracking of the status of all requirements during the project. So monitoring such a status will help on identifying actions based on the change of requirements. So you might have a rejected requirement, and then the next status for the requirement could be deleted. Or you might have a proposed requirement by stakeholders, and the next status for the requirement could be approved. So monitoring the status of such requirements will help for sure to identify the actions over each change in the requirements and how we're going to control this. In addition to the changes and identifying the requirements, so we could adapt to any change in those requirements, it's also good to provide version control to the requirements, which is considered as another essential aspect of requirements management. Every version of a requirement needs to be uniquely identified in the same way as each requirement. The last version of a requirement must be available to all team members. Changes need to be documented and clearly communicated. That's part of the documentation. That means we do need a version identifier that is assigned to each version of a requirement, which must be updated with every changes to the requirement. That means to provide a version control, the requirement documents should include the version, a revision history that has changes, dates, who has made such a change and why this change has been made. Also, we should have standard markers for revisions. That means you could either use strike through or underline text or coloring or line markers, whatever will show the changes in the documentation. Version control tool may be used at this point to either store and manage the revision history or to even store justifications to such changes, which might include to add, to modify, to delete, to reject a requirement. So the first phase of requirement engineering process is to provide identification of the requirements, in addition to provide identification to the versions of the requirements and the attributes of requirements. The next stage would be traceability. So requirement traceability refers to the ability to describe and follow the life cycle of a requirement. So we'd like to trace the entire path of a requirement. This could be done in two ways. It could be either forward direction or could be backward direction. So when we talk about forward or backward directions, that means from its origin through its development and to the specification to its subsequent deployment and use, and through all periods of ongoing refinement and iterations in any of these phases. So when we say we would like to trace the requirements, we need to trace requirements not only in the development phase, it might be during the specification phase, it might be even during any subsequent deployment and use of such requirement. A software requirement specification is traceable if we actually understand the origin of each of its requirements, and that means the origin is clear, and if we have a facilitation of the reference of each requirement in future development or even enhancement documentation, we say that a software requirement specification is traceable. Why we need traceability? Because traceability gives essential assistance in understanding not only the life cycle of the requirement, but also the relationship that exists within and across software requirements with each other, requirements and artifacts or elements of a system in the design and even in the implementation phase. That means a link or relationship defined between entities that will help in tracing those relationships between requirements and the life cycle of requirements. Traceability is often mandated by contracts and standards, which commonly seen in military and aerospaces. Traceability cannot be managed if we cannot actually like you cannot manage something if you cannot trace it, right? So that's why traceability is important. Traceability information helps assessing the impact of the changes. So if you can trace the life cycle and the requirement with the version of changes, with the changes over each requirement, in addition to the links and the relationship between requirements, it can be easily used to assess the impact of the changes or two requirements, connecting these requirements as well as requirements for other representation of the system. That's why traceability is important. Traceability is a property of a system description technique that allows changes in one of the three system description, either requirements or a requirement analysis and specific analysis phase or specification phase or even implementation phase. Traceability helps to trace such changes in requirements in those three phases. That means we can trace the corresponding portion of the requirements even in other descriptors or other phases of the software requirement engineering process. The correspondence should be maintained through the life cycle of a given system. So related to traceability, and we were able to see that traceability helps in assessing the impact of the changes. Also, it allowed changes in one of the three phases of system descriptions to be monitored and to be assessed. Requirements cannot be managed effectively without requirement traceability. So we have this definition which claim that a requirement is traceable if you can discover who suggested the requirement, that means the owner, why the requirement exists, what requirements are related to, which means relationship between requirements, and how that requirement relates to other information, not necessarily to another requirement, but also to system design, implementation, and user documentation. That's how we say a requirement is traceable. Benefits of traceability could include prevents the loss, any loss in knowledge, supports the verification process at some point, which includes certification and localization of defects. Also, it helps in identifying or assessing impacts of the changes. That means it's really crucial in impact analysis. Also, it provides an image or a ground truth to the changes to control the changes in requirements. Also, it helps in process monitoring. Means we can easily monitor those missing links at some levels between the requirements and other components that will indicate if we have a completion level of requirements or if there is something missing. If we can monitor or we can trace the requirements, the life cycle of requirements and the links, the relationship between requirements and the changes in requirements. This traceability helps in improving the software quality. That means it will help in making those changes correctly and completely adapted and applied. Also, requirement traceability. Those traceability links are commonly defined in the re-engineering process, in which they are commonly used as a way to record reverse engineering knowledge. Traceability helps in reusing requirements. So if you can trace requirements at some point, if there's a need to the reuse, this could be easily adaptable. This could be done by identifying what goes with the requirement whether in the requirement phase or in the design and code. So if there's a need to reuse it again, I can easily reuse such requirements. And finally, traceability helps in reducing the risk. So if for example, a team member with some key knowledge leaves the system, tracing the requirements and even document such traceability outcome in a documentation where we can see the version of the requirement, who has done it and what actions and why, would help definitely to reduce the risk in the entire requirement engineering process. So what are the main traceability difficulties? It might be related to the fact that various stakeholders actually require different information. So if they require different information, it might be hard to trace the entire relationship between requirements. Also, huge amount of requirement traceability information must be tracked and maintained. So storing such amount of data related to traceability information might be challenging. Manual creation of links is very demanding. Likely, it's the most annoying problem in requirement traceability. Also, it needs specialized tools that must be used to trace requirements and their relationship with other element system artifacts. Integrating heterogeneous models or information, even from or to different sources, whether it's requirement or design or test code, documentation rationale is not a trivial process. So this is the main reason why traceability is difficult. Also, traceability requires organizational commitment with an understanding of the potential benefits. Otherwise, if there is no organizational commitment, maybe the traceability file that you have extracted might not gain enough agreement among all the stakeholders at some point, which will not help to have a global benefit among all the organization leveling. So what are the main types of traceability? Traceability could be backward or forward. Backward traceability means we go back to previous stages of development. It depends upon each element explicitly referencing its source in aerial documents. Forward traceability, on the other hand, means we are tracing the requirement to all documents spawned by another document in a future leveling in the system. Forward traceability depends upon each element in the document having a unique name or reference number. So as you can see here, forward traceability, we start by business plan, and then we're going to trace the requirement in the requirement documentation, and then we're going to trace the requirement forward in the design specification. If you look for backward traceability, you start backward to previous stages of the development. So I'm going to go backward to the requirement documentation and do traceability on the requirements. And finally, if there is a need, I will go to the business plan and trace the life cycle of my requirement. So if we look to top to bottom from requirements point of view, we could have forward to traceability or forward from traceability. Forward to traceability means that links other requirements which may have preceded the requirement document to relevant requirements. When you link other requirements that may have preceded the requirement documentation, this is really good in validating the requirements and also evaluating the effectiveness of each requirement and what has caused changes to such requirements that will satisfy the user needs. Forward from traceability, it links requirements to the design and implementation component, which help assure that all requirements have been satisfied. If we look now not from top to bottom from requirements point of view, if we look from bottom to top from requirements point of view, when now we're talking about backward traceability. Backward traceability could be backward to, or it could be backward from. Backward to traceability, actually it links design and implementation components back to the requirements. It helps in determining why each item is designed and implemented. On the other hand, backward from traceability, it links requirements, but to their sources in other documentation or people. Again, backward from traceability helps in validating requirements and also evaluate how changes to requirement impact stakeholders' need. So whether it's backward traceability or forward traceability in terms of the strategy of tracing the changes in the requirements and the relationship to other requirements, or the life cycle of requirements, what are the main types of traceability? It could be source traceability, rationale traceability, requirement traceability, architecture traceability, or design traceability. So source traceability, they link requirements with a person or document. Rationale traceability, they link requirements with other requirements and monitor the rationale of each requirement to other requirement. Requirement traceability, link other requirements which are in some way depend on them. So it's not about rationale of the requirements to each other, it's about the dependency between the requirements. Architecture traceability, they link requirements with the subsystems where these requirements are implemented, particularly important where subsystems are being developed by different subcontractors, as an example. Finally, design traceability, the link requirements with specific hardware or software components in the system, which are used to implement the requirement. In addition to source, rationale, requirement traceability, architecture traceability, and even design traceability, we also have interface traceability. Interface traceability are those are this strategy that are considered those strategies that links requirements with the interfaces of external systems, which are commonly used in the provision of the requirements. Feature traceability is a strategy in which you trace the features of the requirements, and maybe there are changes across different versions. Test traceability are this traceability technique or approach in which you link requirements with test cases. Those test cases are verified and later on will be used and implemented along with the requirements. Finally, the code traceability, generally not directly established, but can actually be inferred. So code traceability is not, is hard. There's a lot of research area about code traceability, especially using machine learning, but it cannot be inferred, it's hard. So if we would like now to provide a model to traceability, like whether it's interface traceability, feature traceability, test traceability, or any other type of traceability, what are the main representation format that we could easily use it to trace requirements and with requirements or requirements with system artifacts or requirements with system elements? It could be like with design documentation, or it could be with code or test cases. There are different representations that are commonly used to represent traceability. The first one is called traceability table. Traceability table is very efficient because it shows the relationship between requirements or between requirements and other artifacts. The table can be set up to show links between several different elements. The table can be traced either backward or forward. But it's difficult to capture different type of links in such tableau format. So in the traceability table, we store information about user requirements, as an example, functional requirements, and other artifacts in the system, like design elements and code module, whatever module for the coding, and the test cases. So you can see here, like if we have the UC, the use case, the user requirements at 28. The function requirement is catalog.query.sort, which class in the design this is mapped to is the class catalog, and which function or module in the code this is related to is the catalog sort. And the test case could be either search 7 or search 8 based on the status of search. So this tableau, traceability tableau, provide an identification of an overview of the links between requirements, but not all the types of the links between requirements. So that has created a need for traceability matrix, which is considered as another representation of traceability. It defines links between pair of elements, a requirement to a requirement relationship, a use case to requirement relationship, or even a requirement to test case relationship. Traceability matrix can be used to define relationship between pairs. What kind of relationship we could see it in the traceability matrix? We could see specifies, like requirement A specifies requirement B, or so requirement A specifies requirement B, or requirement B is specified by requirement A, or requirement A depends on requirement B, or a requirement B is a part of requirement A, or requirement A constrains requirement B. So different format or 4 different forms of links that we can see in the traceability matrix, which was not seen in the traceability table, include a specifies relationship, dependency relationship, inheritance relationship, or constraint relationship. The traceability matrix is more amenable to automation as compared to traceability table. As you can see, if we decide to build the depends on relationship, I could build one traceability matrix. If I have multiple relationships, I could build multiple traceability matrix. So that depends on, it could be binary representation, or it could be asterisk representation, or it could be a numbering representation. As you can see here, requirement 1 depends on requirement 3 and requirement 4. Requirement 2 depends on requirement 5 and requirement 6. Requirement 3 depends on requirement 4 and requirement 5. Requirement 4 depends on requirement 2. Requirement 5 depends on requirement 6, and requirement 6 doesn't depend on any other requirements. So tracing trust relationship helps on identifying conflict in requirements, identifying if a requirement change, which other requirements would also change, using the depend on relationship as an example. So if we monitor a change on requirement 6, we know for sure that requirement 2 would need to be like there's a change of control that should be established for requirement 2 and also for requirement 5. So traceability matrix as a form or a representation form to the relationship between requirements or in other elements in the system is really efficient to provide an overview about the relationship between such components. At some point when there is a change in some of those components, it's easily traceable. That's why we call it traceability matrix. So I can trace the changes of one requirement and its impact on other requirements. So we could have a depends on traceability matrix, or we could have specified by relationship, or could we have an inheritance matrix, or could we have a constraint matrix? So maybe for the entire set of requirements or the system components, I could have multiple traceability matrix. It's a better visualization tool to identify the relationship between requirements and other system components. So in addition to the traceability matrix, there's a third representation, which is called traceability list, which has been adopted or like initiated and proposed. This is mainly because traceability matrix, the size of the traceability matrix has become very big, especially if we have a lot of requirements. And also most of those matrices are sparse. Sparse means there's a lot of missing values in the matrix, because I might have requirement 1 related to requirement 100, while the 99 requirements are only of relationship, like 5 relationships or 5 entries in the matrix. So the entire matrix has 100 requirements, but at the same time, there is no much entries in the matrix. So traceability matrices become more of a problem at this point, especially if there is hundreds or thousands of requirements as the matrix become large and even very sparse populated. So they came up with a simplified form of the traceability matrix. This form is called the traceability list, which actually contain a description for each requirement. One or more list of the identifiers of related requirements are actually maintained. So you can see here, I can easily just store which is requirements requirement 1 will depend on. So I would say requirement 1 depend on R3 or R2. I don't need the entire row of the 6 requirements. I just need to store only the information needed in a list form for each requirement without the need of creating, if we do have n requirements, so I would need to store n by n matrix size. With the increased size of requirements, this is very big. For the traceability list, as you can see here, I only stored 6 rows or like 5 rows. So that's 5 rows. And I only stored the information about those requirements that I will need. So the max number of entities in such row would be a maximum of n. So this is way less as compared to the n square matrix size. So that's why traceability list is recommended in most requirement management tools. So the question is, do I need to plan for traceability? Yes. Traceability planning is mandatory because it's just like any other project. You need to identify who are the stakeholders, what are the needs, especially for analysis and generated reports, identify those useful, measurable, feasible objectives. Also, you need to define links and attributes, and you should come up with a conclusion whether some of those links and attributes could be actually inferred automatically or not. That's part of the traceability planning process. Also, in addition to the traceability planning procedure, to identify stakeholders, the needs, and the links attributes, you need to identify who collects and when to collect traceability information, the entire process of traceability, including roles, access permissions, data links, input and updates, exceptional situations, when related to time, as an example, of lack of time. Also, representation, are you going to use the matrix? Are you going to use the list? Are you going to use a Tableau? What kind of queries we could apply to extract changes in requirements, and tools that will help on identifying changes and trace the requirements along the requirement lifecycle with other components. In addition to all of these major steps or stages in planning for traceability, you need to include traceability policies because it helps on defining what and how traceability information should actually be maintained. So during traceability planning, we cared about identifying stakeholders, the analysis and reports, definition of links and attributes, and the main process of traceability planning, and representations. So what are the main factors that we should consider in all of these steps? So we should consider the number of requirements. The greater the number of requirements, the more the need for formal traceability policies. Also, the expected system lifetime. More comprehensive traceability policies should be defined for systems which have a longer lifetime as compared to those systems that would have a shorter lifetime. Also, maturity level of organization. Detailed traceability policies are more likely to be implemented and used probably in a cost-effective way in those organizations which actually have a higher level of process maturity. Finally, you should also consider the size of the project and team. The larger the project or team, the greater the need for formal traceability policies. So these factors are really considered during traceability planning to provide an efficient planning for the traceability procedure that you're going to perform to trace the life cycle of your requirements and other system artifacts. In addition to the number of requirements, expected system lifetime, maturity level of organization, and the size of the project team, we could also consider the type of the system. Critical systems such as hard real-time control systems, or even safety critical systems, definitely would need more comprehensive traceability policies than non-critical systems. In addition to identifying the type of the system, we should also consider any additional constraints from the customers, especially that we have different standards like that we should align to. So traceability links also are a big factor in considering traceability planning process, because traceability links should be defined to identify the links between and relationship between requirement and other system artifact. This could be defined by whoever has the appropriate information available. So as you can see in the following tableau, we do have information about the link between a source and a target, the source object and the target object, and of course the information source, who has the appropriate information available about this link. So the source could be a system requirement, and the target requirement is a software requirement, so there might be a relationship between them. who has initiated such link is the system engineer. The use case and function requirement, they might be related, like the source and the target one. And then who has initiated this, the requirement analyst. This information also should be collected in order for us to provide better traceability planning that will be later documented for efficient requirement change control. So how to model traceability? So now we identified different type of traceability, representations of traceability, but we need to also understand how to model traceability. So the type of links to use and along with their attributes must be defined for different type of requirements. At this point, traceability modeling is considered as a design problem. Uh, Actually, we have seen a lot of modeling techniques so far that will help in modeling traceability. Some of them, which we have learned before, related to UML class diagrams. And more or less, we are building a meta model here, such as that object type would be considered classes, object attributes, they would be the attributes of the requirements, the structure of folder, module, and objects will help in the composition of requirements. And of course, the links type in the class diagram will help on identifying association between requirements. It could be satisfied, test, refine, contains, contributes, and threading, and even justified. Finally, the link attributes, it could be related to the association between classes that it could be depends on, or it could be specified by, or it could be a parent relationship. So I could easily use a UML class diagrams to actually model traceability. So what are the main types of traceability links that we might see? We might see different types, as I said before, related to dependency. We might see specified by, we might see inheritance relationship. We might actually see something related to requirement contributes to other requirements. This requirement contradict with this requirement. This requirement justify this requirement, or even like, of course, that depends on relationship. So the relationship, the types of traceability links that we might extract between requirements, actually it helps in identifying conflicts between requirements. So if I'm going to build the traceability matrix or a traceability list, and I'm able to extract the conflicts relationship between requirements, I will able to trace such conflicts and provide a conflict detection scheme of those requirements. And later on, maybe through negotiation, I can easily negotiate such conflict. So we might use negotiation to resolve such conflicts. So in addition to all the type of links that we have seen so far in traceability links, actually we could see other, like there is no limit on the number of traceability links that we might add to our traceability analysis. So we could even have modifies link, or we could have is satisfied by link, or is implemented in link, verified by link, lead to the creation of. So you could add as many as you want in the traceability links of the traceability representations of links between the requirements and other system artifacts. The more links types you add, the more detailed the traceability of such requirements or such links that is helpful on identifying what actions could be made when we see change in requirements. So do we have cardinality for those traceability links? As a matter of fact, is we could add key terms on each link between the requirements. And we also could add cardinality on the traceability links. The cardinality of traceability links, they actually depends on traceability information, but it could be one of three types. It could be one-to-one, which means one design element to one code module, as an example, like one-to-one relationship, or requirement one and requirement two relationship, just one-to-one. Or it could be one-to-many. So I could have one function requirement verified by actually multiple use cases. So I should have one requirement and use case one, use case two, and use case three. So this is one-to-many relationship, or it could be many-to-many relationship. We could have a use case may lead to multiple functional requirements, and the functional requirement may be common to several use cases. So this is where we have many-to-many relationships. Those cardinality of traceability of relationship between requirements or other system artifact may be added to the traceability I call it graph, like similar to this one before, where I can see all the links between requirements, whether those requirements are business requirements or user requirements, or even functional requirements, non-functional requirements, software test cases, software design, documentation, everything. Once you plot the traceability among them, it's easily at this point to monitor the impact of a change of one requirement to other components in the system by just looking to the traceability graph, which can be easily plotted by either the traceability matrix or the traceability list. So once we built the traceability matrix, once we constructed the traceability matrix and maybe build a traceability graph from the matrix, we need to provide change detections to identify the changes of each requirement. And once you identify such a changes, you need to manage the change. So when it comes to change management and requirements, it is actually concerned with the procedure, processes, and even the standards, which are used to manage changes to a system requirement. A change management always come with change management policies. Change management policies may even cover the change request process and the information required to process each change request. In addition to this, it may even cover the process used to analyze the impact of the change and the cost of such a change and the associated traceability information. This could be in the policy. In addition, we could see the membership of the body that formally considered the change request. So with every change, there is detection of the change and there is a request of the change. There might be some changes without request, and mostly we always have a change with requests. A change management policy should also cover the software support, if any, for the change control process. So if we do have a change request, it may have a status as well as requirement. So a change request could be either a proposed change or a reject, or that means the change request is proposed, or the change request has been rejected, or maybe the request for such a change has been accepted, or the change request may be included. So similarly to requirement status that we talked about it before, we could also have a status for a change. So in a change management process, some requirements problems should be identified. And this actually could come from the analysis of the requirements, the new customer needs, or even the operational problems with the system. The requirements are analyzed using problem information, and the requirement changes at this point are proposed. So the proposed changes are then analyzed. So first stage is to identify the requirement problems and to come up with a list of proposed changes. And then you analyze such changes. When you analyze the proposed changes, that means you are looking to answer questions as how many requirements are affected by such a change. Later on, you need to come up with an answer to how much would cost in both time and money if such a change is verified or accepted. So once we accepted the change, that means the change is implemented. A set of amendment to the requirement documents or a new document version at this point is produced. Of course, this should be like validated with whatever normal quality checking procedure in place. So if we look to the change management process, it starts by identifying the problem, which means we have to perform a problem analysis and a change specification. You identify the change and specify it. And then you do change analysis and costing. What would happen if I will actually accept the change? Maybe my decision later will be implementing the change or rejecting the change. If you're going to implement the change, so we now have a new set of revised requirements. So if you would like to provide a change request, there is a formal change request form in which all the proposed changes are recorded in this change request form. And then this change request form is then passed to all the people involved in the analysis of such a change. A change request form actually may include information related to date, customer, who is the requester, and the product, including versioning, description of a change request, including the rationale of such a change, fields to document the change analysis, signature feeds, status, and final comments if needed. So if we look to once we have the change request form, and then we will analyze the change and the cost of such a change, and then later on we will accept or implement the change. I would like to share with you how the change analysis and cost could be performed. So you have a change request. The first step in the change analysis and costing, you would check the request validity. At this stage, you have two options, either to reject the request or you say it's a valid request. If it's a valid request, you need to find directly what are the main affected requirements, and then came up with a requirement list and find the dependency between requirement and the outcome at this stage will be a requirement change list. So including customer information or customer feedback, we will propose changes to the requirements. We could either, we have two decisions at this point, either to change requirements or to again reject the request. If we have requirement change, so at this point, we need to make an assessment of the cost of such changes, and we have cost information. We're going to assess the cost acceptability. So the decisions, the final decisions based on the involvement again of customer information or customer feedback could be either to reject the request or to accept the change, or also reject the request. I think this is just like a duplicate. It's just like two actions here. Either you reject the request or accept the change. That's it. These are the main changes and costing example that we might commonly see it in cost change and cost change analysis and costing example.